Okay. And once you do that, once you separate it, now you just integrate both sides. Usually on a free response question, doing this is worth 5 points to solve a differential equation. If you don't separate the variables, 0 out of 5 for you. So very important. No, this whole problem, 5 points. So when you have like 1 over y minus 1, what would be the antiderivative of that? What's the antiderivative? ln, right? Because the derivative of ln of u is 1 over u, or u prime over u. Since this is just y minus 1, it would be ln of y minus 1. Does it make sense why I put the absolute value bars in there? Did I tell you why I put the absolute value bars in there?
Yeah, but I don't remember.
Because you can't take the ln of a negative number, and so when you do the antiderivative, you always put absolute value bars around it because you don't want it to be a negative. So like if you plugged -3 in there, it would be undefined, but if you put absolute value bars around it, then it's now defined. And so when you do the antiderivative, you always just put absolute value bars around it. Usually they get dropped later, but that's what it is. This is not ln, right? Because this is the same as x to the -2. If it was just x to the first, it would be ln. But this we can just do the antiderivative, right? Add 1, divide by that, so that would be -x to the -1 plus c. And I don't have to put a plus c on both sides because like it's just one constant. So you just usually put it over here with the x's. Usually on a free response question, doing the antiderivatives is worth 1 or 2 points. Sometimes it's a point for each side, a point for plus c. So as long as you separate your variables and do a plus c, you at least get 2 points. And then you have options, all right? The goal is to solve this equation for y, but they also give us a point so we can solve for c. And so we have to decide if you want to solve for c now or you want to solve for c later. What did I do normally? Normally I solve for c right away, right? That's what I do, because once you start doing stuff to both sides, it affects the c. Like if you e both sides, then now that's e to the c. And so I normally solve for c first, but you're going to see on some examples of free responses, you can wait till later if you want. But that's usually what I do. That's worth a point. So this is x and this is y. So if I plug in 0 here, I would get ln of 0 minus 1 equals, why did I clean that up? But that's okay. -1/2 plus c. Do you agree with me on that? Because the x and the -1 is really the x on the bottom. And this is where the absolute value bars are important, because 0 minus 1 is -1, but it's the absolute value. So what is the ln of 1? 0. So this is just 0 equals -1/2 plus c, or c equals 1/2. Usually you get a point for using the initial value. That's what it says. Which means taking that point, plugging it in, and solving for c. And then the last point usually comes from solving for y. So I'm going to go back up here, and I'm going to write ln of y minus 1 equals -1 over x plus 1/2. You with me on that? And then what am I going to do? How am I going to get rid of the ln? I'm going to e both sides. Because e and ln are inverses. So then I get y minus 1, I set the absolute value bars around it, equals e to the -1 over x plus 1/2. And then I do this in the video of like how do we figure out if it should be positive or negative with the absolute values.
Yeah, that was mostly x's. That was kind of more of a possible one.
Someone was a disaster in that.
It was so cute. Also at the end you were like, say bye Nolan. Or you hi. I thought he was going to say bye Nolan instead of like just bye. I want a green. I don't see green. I just want some. Rainbow. I want the clear one. Yeah. I want white. Like, why white?
It's so distracting.
Like this? Yeah.
You guys always appreciate what I write on it. One time Nolan wrote on the Algebra 2 one and someone commented, That was really distracting. Can you not do that again?
Are you serious?
Rude.
I'm sorry, I have
Slap
children
that
to
kid in
watch.
the face.
Like, would you rather
Don't talk to my
video
kid
of you
like that.
screaming at them?
The mom job 24/7.
Right? Like, you know, I had to
What
put
do
you
you want
in
me to
here.
do about it?
And so this initial value is what helps us figure out if we need positive or negative. Is that true? Or we just set each one up? Do you remember?
No, you said that.
You said up there with the F whatever.
X.
If it's positive or negative.
Oh, with this
0.
one, with this one we have to see where it equals.
That's not negative.
Stop
Is
going.
0 a positive?
So I think 0's neither.
I think
Yeah.
So
It doesn't have a negative.
There's no negative
Well,
sign.
in this one we just.
so what about this?
Go.
Okay, just let me do something.
Okay, you do you. I'll wait.
So what if we say that it's this, right? If we leave it like this, the question is, does that work? If we add 1 over, we would get 1 plus e to the negative 1 over x plus 1/2. You with me on that? If I just drop the absolute value of ours, leave everything the same, that's what I would get. But I have to check that that initial value makes that true. And if it doesn't, that means I need the negative, because absolute value always has 2 options. And so if I plug 2 in here for x, I would get negative 1/2 plus 1/2, which is 0. And what's e to the 0? And 1 plus 1 is not 0. So that means we need the negative. So what that means, here, let me give you a little reminder. If you have the absolute value of x equals 2, that means x equals 2 or x equals negative 2. You make this side negative. So what that tells us is we need the negative of this, right? So we need this to say y minus 1 equals negative e to the negative 1 over x plus 1/2. So you're still dropping the absolute value bars, but we want the negative solution to that absolute value based on the initial value. So my final answer is going to be, and you add the 1 over, wherever you want to do it, but it's going to be 1 minus e to the negative 1 over x plus 1/2. 5-point free response question. If you messed up the negative, you can still get 4 out of 5, which is a really good score, right? Just on that one part. And so, again, do your best on it, but no, you don't have to get 9 out of 9 on all of these to do well on the test. If you can get a solid 4.5 on like 3 of the 6, like you're good to go.
Our homework is AP questions.
What the heck, man?
This is ridiculous. We got through. It's
Nope.
only
Quit.
You're not allowed.
I will just never show up.
This is not homework yet, though. Yes, this is not homework.
This is my homework.
Correct.
This is an AP question. And notice there's only two parts, and this is 9 points. Oh my gosh.
What is that saying?
2y? I think that's
I don't know.
2y.
I can't read it on here.
It's got to say 2y because it's dy.
I don't think it doesn't
look
look
like
like
a
a
Y
Y
on
at
the
all.
It's 2y.
No, I agree.
It's a 2y.
That's
I promise.
okay.
I promise.
Wait, can you look at this in your notes?
I believe you that it's hard to read. I'm just telling you. I'll look it up to verify, but I'm telling you that's what
Well,
it says.
look it up now so we don't do the whole thing wrong and then be like, it's
It's
not
funny.
Y.
She just rolled her eyes.
Well, what's new? I'll be the first
Give
one.
us the answer. Wait, what does that say? I know, what is that?
No time for this.
It's not a Philly cheesesteak day. For any of you guys.
Oh, that's the only thing I ever get at Subway.
Is it
That's a
actually
blind
like-
person.
like Braille on the
Braille
Subway?
day?
Looks like Braille on
Not
the
like
subway.
the Subway.
Braille on a subway?
No, it's like the mats.
So
So they're close to the edge.
I'm on it, y'all.
So they don't
So
fall over.
you should have sliced beef. I just don't like
What?
it.
It's 2y, kids.
Okay.
Yes, I just don't like any type of. No,
It's
oh,
celebrating Seichi Makai.
What do you do?
I don't know.
Miyaki. Japanese inventor.
What do you invent?
I don't have time for this. We only have 10 minutes of class left.
No, it's
Oh,
whoa.
you're.
Oh, my clock's way off.
What happened?
Your computer's way
Why is your clock that much?
30 minutes.
Wow.
8:50. We're good. I was freaking out. I only ever look at the minute hand on the clock,
Yeah.
and so I was freaking out. I was like, how did we really spend this
Why
much
is
time?
it? Why is it like
Why is
that?
the light?
I don't know, because the battery's dying, I think. Because it's 6 o'clock in the morning.
might be
So
sleeping.
snippy at me.
Separate your variables.
See, and then she goes this. Separate your variables. Oh my. See, we've tried out this thing, I'm telling you.
Guess you'll do good on my surprise quiz this week.
Well, it is question mark.
Are you really?
So we're gonna have one.
I said I was going to give you one on the day we get back from spring break.
But I'm not gonna be here. Because I'm not coming.
Most people aren't, right?
It seems stupid.
I didn't even
You're skipping that.
I'm always here.
Okay, so step one is you have to separate and you have to pay attention. Are you multiplying or are you dividing? And on this one, since it's dividing already, you multiply it over. So just pay attention to what you're doing there. So now integrate.
You're so sassy today.
I just want to do math. Is that asking someone?
Yes, right now. Currently.
I promise. Actually, I can't promise I won't make you do math later on. I'll try
It's
not
not gonna
to
happen.
do math.
If you ask me to do it, I'm not gonna do it. I'm on vacation.
you guys at the restaurant. You're
When
like,
we went to Ecuador, I took a practice AP test with me to do on the plane.
You're such a nerd.
That's
what
really
the
awesome.
heck? That's so weird.
Take a vacation.
But then I get car sick. Like if I try to read or do something in the car, I get sick. But I thought being on the plane would be different, and so like on the plane I was doing it, and I was like, I don't think this is a good idea.
Did you stop
So
or
I
did you
just
keep going?
no, I stopped and I didn't look at it again the whole time. So,
That's good.
but I did work on it in the airport, and on the way home we have a 5-hour layover
Oh my.
in Newark.
Oh, that's a bad airport.
5 hours on our before we get on our last flight to come home.
That's terrible.
So we should bring some calculators.
I was in the airport for 8 hours on the way back
That's
home
a
from
bad
Houston.
airport. My mom says.
My husband's like, I could just drive and pick you up at that point.
Yeah, you might as well.
But not really. It would be more than
Yeah,
5 hours.
5 hours.
Mr. Love's group, they only have like a 3-hour.
Yeah, they got home 2 hours.
They get home at 5:30, and we don't get home till 9:30 at night on Saturday. Because Mr. Rhodes doesn't want to get up early to catch an early flight. But you would complain if you get up at 3 in the morning for a flight too.
You guys are gonna be so dead.
I just went
Yes.
to bed.
5 hours in Newark, we're gonna
Yeah, I'll
be
be
dead.
home.
Yeah.
Screw you. Sucks to suck.
Are you in Mr. Love's group?
I'm in Dallas.
Oh my gosh.
Wait, so what time do they leave? Because they leave earlier than us.
No, they changed it. So we all leave on the same plane from Berlin back to Newark. But then in Newark, they leave 2 or 3 hours before.
No, like on.
Oh, I don't know. I haven't even looked. Mr. Dean just asked me what city we fly into, and I was like, we Berlin and then somewhere else. I go, don't tell Mr. Rose I don't know, because I'm supposed to know as a chaperone, but I'm just following the crowd. I have no idea.
We fly from DC. We go to DC, then we go to Frankfurt, then we go to Budapest.
I don't know what I'm doing.
Colorado and Colorado.
You guys are going to Vienna. You guys go to New York to Vienna. Vienna to wherever. Where are we going into? Prague?
No.
Budapest.
No, we're going from DC. We're flying from ND to DC. We're flying from ND to DC.
Oh, yeah.
From DC to Frankfurt.
No, I meant, but then what's our final one?
Oh, I
That's what I'm saying. I don't know either.
Budapest, isn't it? I think it's Budapest.
I packed my travel folder already with the information in it, so I
I
have no
haven't had
idea.
mine. Mine's in my.
I don't even care. I'll just follow people and they'll tell me where to go, and I'll go to the gate and I'll
I just show up. I don't have to direct anyone.
have it on our way
Oh
home.
my
everywhere.
gosh. What happened?
Yeah,
Did you get
Alex. Or just Alex and she's
No,
Mrs.
we.
Hodge had to talk in Spanish.
Mrs. Hodge, that was before we even left Ecuador. But when we got back to Florida, all these kids said they touched animals, and so then they thought we were contaminated. And Miss Dowd, actually, Miss Dowd and I were the only chaperones that got hoarded with all these children, even though I pressed the button that I didn't touch any animals. But they still, they're like, you with them? And they kept my passport. I was like, ugh. And they're all freaking out because we're like in the basement of the airport, and we just keep going down more tunnels, like deeper into the airport.
Oh my god.
And I'm like, and everyone's freaking out, and I'm like, just calm down.
Don't
Yeah,
love
you didn't have to pet a llama, then we wouldn't have needed it though.
You didn't have to.
Maybe you shouldn't have pet every dog you saw on the streets of Ecuador. Or you should have just lied on the survey, kids. I would have
Lied on the
So
survey.
you didn't touch an animal.
Would have lied.
So I lied. I touched a llama too. I touched a llama too. And so then we get there,
It
and,
was in the history books for
I just
causing
had
the
to know,
Black
like,
Death
fixing the
Part
llama and, like, hugging it.
and so then I'm like, we went to a farm, they pet some llamas, and they pet some dogs. And they're like, oh, okay. And then they turn around, the person behind them, they just pet some llamas, and then they let us go. But like, everyone else had already went through, and so there's no coming back. So Mr. Rhodes and Mr. Love are just waiting after the checkpoint, like waiting for us because like we just got all.
That could have been bad if your flight was, like, right at the, you had to, like, make it to the
Yeah.
gate. That could have been bad.
Because we just got like, I thought they were gonna like check our shoes or like I thought they were gonna check for like manure or something like with the way they like hustled us all this way, but no. As soon as I told them we just touched the llama, they're like, okay.
My sister was like, do you have to run to any, like, other planes? And I was like, no, we have, like, hour layovers between. I don't think we'll...
Yeah, I don't know. An hour is really not that long, depending on like, how big the airport is.
5 hours.
We had, I thought we had, like, 2 hours.
I don't know. I'm not worried about it. Well, I'm just following the crowd. I'm not important enough to make these decisions. Hey, how would you integrate this, kiddos?
Well,
I just follow whatever you do.
What is the derivative of e to the u?
you prime over time. No.
Idiot has you wrong.
What's that?
Right? And so, if this is my derivative already, this is kind of a u substitution thing.
Ugh.
Or think about what you need for your license to integrate. I don't know how you want to do it, but think about if your u was 2y. Well, speaking of that, I should like take that homework thing then. Right? Or did I check all that u substitution stuff?
I don't know.
Then your
I don't know what you
du
do.
would be 2 dy. Basically, you need a 1/2 here in order to just say that the antiderivative is e to the 2y. You with me on that? Like the pattern part that's missing? But again, I don't know where you are with this u stuff. It's all u's. Like, do you like rewriting it? Like, I could rewrite this as 1/2 e to the u du by doing my substitution. Or if you just recognize you need a 1/2, you could just put the 1/2 there. It's up to you on how you show that work. But if rewriting it with u is helpful, then you can use the u.
Is that equal to the 3x?
Yeah. And so this would be 1/2, and the antiderivative of e to the u is e to the u, but I'm going to go ahead and write it as e to the 2u on this side.
I'm sorry, this comes over the first time.
It's definitely going to be on the test.
Could have been mine now. I just like
If you forget the 1/2 part there, you're going to miss a point for your antiderivative. But if you continue to use your plus c and you plug in the initial value and you solve for y, you can still get those other points. So don't let something that's hard to integrate make you miss the whole problem. Just keep working in that problem. So now what would you want to do? You want to solve for, oh, why did I put u? It's supposed to say y. This is where I'm going to solve for c first. You could solve for y first, but I'm never going to do that. So this is x, and this is y. So I get 1/2 e to the 2 times 1/2 equals 0 plus c. Which is just 1/2 e. Yes? So I'm going to come over here. So I have 1/2 e to the 2y equals x cubed plus 1/2 e. Yes or no? Now what do we do? We want to solve for y. So what would I do to solve for y?
Multiply by 2.
Let's get rid of the 1/2 first, right? So let's multiply both sides by 2. So then that just becomes e to the 2y equals 2x cubed plus e. Then I'm going to ln. So I get ln of e to the 2y equals ln of 2x cubed plus e. So I'm just showing my work here. But ln of e cancels out. So this is why I didn't use absolute value bars this time. Because 1, e can never be negative. And 2, that just cancels out. And I get 2y equals ln of 2x cubed plus e. And then we can divide it all by 2.
Okay.
Can I distribute the ln or? Because when it just cancel out that e and then it'll be ln of 2x cubed, or can you not do that? Can't do it.
I wouldn't.
You can break up. So here's some ln reminders. If you have ln of x times y, you can break that up as ln of x plus ln of y. But if you just have ln of two things added together, you can't separate that. Even though you really want that e to cancel out, it's not going to.
It ain't gonna
So
happen.
I'm gonna leave this as my answer. I think I have the answer to this somewhere. And then it says find the domain and range of the function found in part A.
Are you kidding me?
And so here's our function.
That blank. 3 points.
Great stuff. I'm not gonna be disappointed because you're not gonna leave the blank.
Depends how much time's left.
It's only March, kids. You gotta give me a chance to get you there. Okay. This is day 1 of doing
We're
these.
already giving up.
You can't give up on day 1 of learning your topic. You can't give up.
It's
It
so
has to be
hard.
the hardest thing. It has to be the hardest thing. It has to. Because I thought other things were, but now I'm realizing it has to be this. Like,
Put it on your list.
really bad. I think so.
Domain. What can't you have in ln? Can't have negative. You can't have 0. So to find the domain of a function that has ln, you just can't have this equal to 0. It has to be greater than or equal to 0. So to find the domain of this, I'm just going to set 2x cubed plus e greater than 0. Not greater than or equal to 0, because it can't be equal to 0. So you have to just think about what is it allowed to be. And then you just solve that. So I'm going to subtract e and divide by 2. So that would be negative e over 2. And then you would take the cube root of that, which is really gross, yes?
Yeah.
But it would just be the cube root of negative e over 2, which you can take the cube root of a negative number. And you could write your domain like this, or I would have written it like the domain is cube root of negative e over 2 to infinity. What about the range of ln? Do you remember what an ln graph looks like? So like just normal ln of x kind of looks like this. Its domain is 0 to infinity, and its range is... So this one, like the range is still going to be negative infinity to infinity. Do you agree with that?
Yeah.
It's just shifted, even though we're divided by 2 here. And so that's where all that stuff with the graphs that we did in Algebra 2 and Pre-Cal, knowing the basic
There's a lot of stuff.
the basic e to the x graph and basic ln graph, to think about your domains and ranges on there. Let me show you. Oh, I closed that already. Because I just wanted to click on the silly and beside it after all.
What? Bless you. said something.
I was like, what did you say?
So, on this one, it was worth 6 points for part A. I will tell you, usually it's 4 or 5 anymore. This was a long time ago. But again, they usually give you a point to separate your variables, at least 1 point for your antiderivative, 1 point for your constant, like remembering plus C, 1 point for plugging in your initial condition, and 1 point for solving for Y. That's a lot of points. If you don't separate your variables, 0 out of 6 points for you. And so you have to recognize if there's 2 variables on the same side, you have to separate those. And then on this one, the domain and range, yeah, that's what we did, right? They did 1/3 power. If you didn't have a logarithmic function in part A to find the domain of, you can't get any points for your domain and range. So they're kind of putting a restriction on that follow through. Like, let's say you didn't know how to do part A, so you just made up an equation to do the domain and range of. If you just made up an equation like 7x minus 2, they're not going to give you points for that. It has to be, like, legitimate. But if you made a mistake up here, let's say you forgot the 1/2, or you had a minus in the wrong spot, but you used that wrong equation to do your domain and range, you could still get the follow-through point. And so that's what I want you to remember as you do these problems, is that there's so many points you can get, even with wrong answers, and so there's no need to feel discouraged, okay? Oh, look, I got more. My plans are already messed up for the week, because we sure aren't getting to this homework.
Still got 12 minutes.
I know, but we haven't even gotten the homework yet, right?
Where's the homework? The homework is, this is the rest of it. And then some homework.
But you were supposed to do the homework in class and have a
That's not
video
gonna
version. You see what I'm saying? So these are just some other practice questions. And so it says, the acceleration of a particle moving along the x-axis at time t is given by a of t equals 6t minus 2. If the velocity is 25 when t equals 3, and the position is 10 when t equals 1, then what's the position function?
What?
Read
That's a
it.
lot.
Read it.
Okay. So you have to take the whole integral?
Yes. Ooh. And so this is where you have to be really careful with your constants, because if you take the antiderivative or the integral of acceleration, you're going to get velocity. Take the integral of velocity, you're going to get position. But pay attention to your constants. That's why they give you an initial condition for velocity, and they give you an initial condition for position. So you just got to solve for those c values. This is not a separating variable problem, because it's not 2 variables on the same side, right? But it's just another integration problem. So I would do and I would get what, 3t squared, because it's 6t squared over 2, minus 2t plus c. If you forget your plus c here, I guarantee the answer is going to be over there if you forget your plus c on both of them. And so remember that this equals the velocity. And so before I take the next integral, I would use my initial condition and solve for c. So I have an actual number, and then I take the antiderivative again and use my initial condition. Yes? So the velocity is 25 at time 3, so this is 25. Oh, this is long math. 27 minus 6. It's long math for Monday morning.
I'm not doing anything on the groups.
C equals 4? There you go. C 4. So now, this is 4. Which you can
Dangerous.
Now you can take the integral of that to get position. But this is one of those questions that is so important. If you forget the plus c, it changes the entire problem, and you miss that question even though you know how to take an antiderivative. So I'm just going to erase and go again here. And that's going to be my position function. So that's going to be 3t cubed over 3, or just t cubed minus t squared plus 4t plus c.
Yeah, put that in.
And now we have to figure out whether you can look and see. It's either going to be C or D as your answer based on what we have here. And so it's 10 when t equals 1. So C equals 6. But sometimes we get so in the habit of having those bounds and forgetting to add C. Like, this is a nice reminder of don't forget your constant of integration. And I haven't put stuff on Khan Academy, but I'm going to. There's a lot of good practice with view substitution and separating variables, and the volume and area that we haven't got to yet, and slope fields. Those are the last things that we're going to be doing before we take a test. And so I'll try to get that on today. It looks scary.
So, I know you got down to C and D, but like, could I go ahead and say C since we already have a +4 since it's not going to change? Or is that too risky?
Oh yeah, sorry, I didn't even notice that.
Okay.
Hold on. I opened my next to this, and I was scared.
Don't look ahead.
I'm sweating.
Don't look ahead.
Alright, what about this one?
Look to the past. The past is in the past. So.
But it's going to be
That's why they call it the present.
So again, we can't forget the stuff that we've been doing, and so this is just kind of a nice little review about acceleration and velocity and net distance versus total distance. Now that we can do integrals, remember that if you just take the integral of velocity, then you get the net distance traveled, but if you take the integral of the absolute value of velocity, you get the total distance traveled. And so this one says find the velocity of the particle given acceleration. Go, do it. Aren't I always bossy?
Yeah, but a little more today.
She's just sassy
Got a little more
about it.
pep in her step.
Come see me 7th hour, I'll have no pep left.
Oh my gosh. You're dead.
Again, I just want to kind of reiterate here, really nice to show work, really nice to explain things. Don't forget your DT when you're writing your integrals. You're just going to sit out there and hope that I would like it.
Hi, Kenzie.
Is this the same one that's up there?
No. Pretty close.
3t squared plus 6t plus c. And again, if you forget your plus c, everything's a mess. And they give you information that the velocity is, at time equals 0, the velocity is -9. So -9 when time is 0. My favorite is when time is 0 because that just gives me c right away. Now, using this velocity function, we can talk about distance that the particle traveled. So, net distance traveled is the integral of velocity from 0 to 2 of this function. And so for part B, I'm just going to do the integral from 0 to 2 of the velocity function, which is I actually have to do it, I'm going to write it out. Technically, I should be putting parentheses around this and putting dt after it. Do I need to take into consideration the initial position if I'm talking about the net distance traveled?
Mm-hmm. No. Yes. What else are you looking for?
I forget. Wait, if it's net, then it goes that way, and it can go back.
Total's the absolute value.
But it could tap.
Total is absolute value.
Net is
I forget.
positive on it.
Net could be 0.
That could definitely be 0, right? So here's the thing. When I'm talking about just distance traveled, the initial position does not play a role in this. because I'm not asking what its new position is. You see what I'm saying? If it said, what's its new position after 2 seconds, you have to take into consider where it started. But if I'm just saying what happened in those 2 seconds, I don't care where it started. Does that make sense?
Yeah.
Like you said, the net distance could be 0, which means I'm back where I started. The net distance could be 42. I don't know. But I'm not going to actually add the negative 27 to it, because it doesn't say what is the new position. It doesn't matter. It's a trick question. They gave this to you, and we don't even need it for either one of these. You don't need a C on this one, right? Because I have my bounds here from 0 to 2. So this is called an indefinite integral. This one is called a definite integral because I'm actually getting a distance out of this, or an area under the curve. That means the same thing. You with me on that?
Mhm.
So if I plug 2 in there, I'm just going to get 8 plus 4 times 3 is 12 minus 18. And again, I love when 0 is a bound because I'm just going to put minus 0 there because all of those are going to be 0. If this was a no calculator question, which it would be because if it was a calculator question, you would just use Math 9, right? You could leave your answer like that, right? Or you could say 12 plus 8 is 20. 20 minus 18 is a net distance of 2. What about if they asked me to find total distance?
You just put absolute value. Absolute value. Yeah. I hope nobody
So here's what's really important, okay? Without a
You can
calculator,
stop recording. Oh wait, she doesn't have her paper out. Never mind.
we'll just keep recording. Without a calculator, you can't just take the answer you got before and take the absolute value of it. You have to break it up at where the velocity changes sign. Like, where does it go below the x-axis? If you have a calculator, that's where you can do the absolute value button on your calculator with velocity, and it really does do it correctly for you. So it's super great if it's a calculator problem. If it's not a calculator problem, you have to figure out where this equals 0. All those are divisible by 3, so I'm going to go ahead and do that, okay? Minus 3. So my hope is that this is going to be factorable. 1 multiplies to give me 3, that subtracts to give me 2. 3 and 1. Or you could do the quadratic formula, but it works. 3 times negative 1 is negative 3, and 3 minus 1 is 2. What? I'm not waiting here. It needs to be battery. Gosh.
Well, it walked in and it says some.
Negative 3 is not in our bounds, yes? But 1 is, so that means you would have to break this up as 0 to 1 of the velocity absolute value plus 1 to 2 of the absolute value. So that's where you do it separately, and if that's a negative number, you change it to a positive. So here's what I want you to do for tomorrow. Do not watch the video that's posted, because we're not there yet. I want you to finish this, and I want you to attempt homework 59, which is 2 questions, right? Free response questions. Try them. Don't Google them. Try them.
I never Google.
I wish.